There are questions so big that even our best equations become metaphors. Today, 5 more cosmic mysteries, each one a crack where wonder leaks in. We'll stay scientific, but we won't pretend science has finished the story. Because the universe doesn't just expand in space, it expands in questions. Mystery 1. What happened before the Big Bang? If before even makes sense. Mystery 2. Are we alone in the universe, or just in this universe? Mystery 3. What is the shape of everything, and what lies beyond the horizon? Mystery 4. Why does time move forward and never backward?
Mystery 5. Do black holes erase reality or preserve it in a stranger form?
In our story, the Big Bang is not an explosion in space, but an expansion of space itself. Run the cosmic film backward, and everything compresses. Galaxies, atoms, even light. At some point, our physics breaks. Density and temperature race toward infinity. To avoid that cliff, cosmologists propose an early growth spurt, cosmic inflation. In a tiny fraction of a second, space may have ballooned faster than light can cross it. Inflation helps explain why the universe looks so smooth and why it's so close to flat. It also seeds the small quantum ripples that later become galaxies. Planck's map of the cosmic microwave background puts strong constraints on many inflation models. But the engine of inflation, the inflaton, or whatever played that role, remains unseen. And inflation raises the sharper question: what started inflation and what stopped it? Some ideas say the universe began from a quantum fluctuation, no space, then space. Others imagine a bounce. A previous universe collapsed, then rebounded into ours. In those models, before might mean another phase of time, with different rules. Right now, we search for fingerprints, subtle patterns in the CMB, and primordial gravitational waves. If we ever detect those waves, they would be the echo of the universe's first heartbeat. Until then, the Big Bang remains a doorway, not a beginning. If inflation happened once, it might happen forever, somewhere. In eternal inflation, inflation ends in patches, like bubbles in boiling water. Each bubble becomes a universe with its own Big Bang, expanding away from the rest. From inside a bubble, it looks like one universe. From outside, it's a foam. This is the multiverse. Not science fiction, but a possible consequence of our math. But if other universes can't send light to us, how could we ever test they exist? One hope is collisions. If our bubble once hit another, the CMB might show a scar.
So far, no scar has convinced the community.
Another route is statistics. Inflation plus particle physics may allow many vacua, many laws. That raises the anthropic temptation. Perhaps we see these constants because only these allow observers. Some physicists hate that. It feels like giving up on deeper explanation. Others see it as honest. If the cosmos is huge enough, rare settings become inevitable somewhere. There's also the quantum multiverse, many worlds, where every measurement branches reality. It's a different idea, but it points to the same unsettling possibility. Reality may be plural. If that's true, that our universe is not the world, just the one our story can reach. Now, even within our universe, we only see a patch. Light has a speed limit, and the universe has an age. So there's a boundary, the particle horizon, the edge of the observable universe. Beyond it may be more galaxies, more emptiness, or something stranger. We can't know directly. We can ask about geometry. Is space flat, positively curved, or negatively curved? Measurements of the CMB and large-scale structure suggest space is very close to flat.
Yet flat doesn't mean infinite. Space could be flat and still wrap around, like a cosmic torus.
If that were true, distant patterns might repeat, like seeing the same galaxy in different directions. So far, we haven't found convincing repeats. And the CMB holds puzzles, a cold spot, and hints of strange alignments. Maybe just chance, maybe not. If those anomalies are real, they could hint at topology, new physics, or overlooked systematics.
Even the fate of the far universe depends on this geometry and on dark energy's behavior.
Some regions may already be slipping beyond our future reach, carried away by accelerating expansion. In cosmic terms, our observable universe may be a lighthouse beam in an ocean of unseen space. And we are born not just into a place, but into a limit. The shape of everything might be the oldest secret we can almost touch. Next mystery, time itself. The laws of physics mostly work forward and backward. But our lives don't. Ice melts, but doesn't unmelt. Memories form, but don't unform. This is the arrow of time. The universe has a preferred direction.
The usual explanation is entropy. Systems move from ordered to disordered, from unlikely to likely.
But entropy isn't a force. It's a bookkeeping of how many ways a system can be arranged. So the real question becomes sharper. Why did the universe start in such a low entropy state? That special beginning is what makes time feel like it flows. Some ideas say inflation sets the initial conditions. Others say a bounce selects them.
Some push deeper. Maybe time emerges from quantum entanglement, and the arrow is a growth of information.
Either way, the arrow isn't just about physics. It shapes meaning. Because an irreversible universe makes choices real. It turns moments into one-way doors. And it makes love and loss possible. You only get one forward pass. We don't yet know why the universe began with such delicate order. But that mystery might be the reason any story can exist at all. Final mystery: black holes, the universe's most extreme punctuation marks. A black hole is a region where gravity is so strong that light can't escape.
Classically, anything that falls in is lost behind the event horizon.
But quantum theory insists information can't simply vanish.
This clash is the black hole information paradox. Hawking showed black holes should slowly evaporate by emitting radiation. If the radiation is random, the information about what fell in seems destroyed. In recent years, new calculations suggest the information may leak out, encoded in subtle correlations.
Ideas like holography hint that the inside of a region may be described by information on its boundary.
If that's true, a black hole might be less like a shredder and more like a library with an alien filing system. But we still don't know what replaces the singularity, where general relativity breaks. Maybe quantum gravity smooths it out. Maybe space-time itself dissolves into something deeper. Some researchers suspect space-time is emergent, built from entanglement, like geometry made of relationships. Black holes could be the laboratory where we finally see the seams. And if space-time can emerge, it can also change. Even time might be a feature, not a foundation. Which brings us back to the beginning. Perhaps the universe didn't start with space and time. Perhaps it started with rules, and then grew a stage to run them on.
In that view, the deepest mysteries aren't failures of knowledge. They're invitations to a larger map.
If you enjoy exploring questions that don't have easy answers, you're in the right place.
Like the video if it helped you see the universe a little differently.
And until next time, keep your curiosity warm and your certainty gentle.